Okay, 12.4 is simplifying rational expressions. We have a lot to do in this little lesson. So let's talk about a rational expression. When you see the word rational, you see the little word ratio. It's like a little fraction, right? So rational, look for ratio. Think about it in terms of a fraction, which means you'll have a denominator. And one of the themes of today's lesson is the denominator, as you know, may not equal 0. If it was equal to 0, what would it be called?
Undefined.
Undefined.
Yeah.
Denominator of 0. So today we're going to see more sophisticated denominators than you have worked with. Much, although you worked a little bit with them. And when we do, we've got to keep in mind that we never want an undefined ratio. We want real, defined rational expressions. So there's such a thing called an excluded value. Any value that would turn the denominator into the value of 0 is called the excluded value. A number that makes the denominator 0. One question we could ask is, what is the excluded value or values? So what value would cause this denominator to equal 0, everyone?
0.
Say it.
0.
Right, so the excluded value here is 0. 4 times 0 would cause that denominator to equal 0. This is not even an equation. Look at it's just an expression, right? So now this one's a little more involved denominator. What value would cause this denominator to be 0, Tara? 3. And so if it's tough for you to see that, set the denominator equal to 0 and then solve that small equation for the value that would cause it to be 0, right? You would add 9 to both sides. 3x would then equal 9. And when you divide both sides by 3, x equals 3. This is the value that would cause the denominator to be 0. So it is the excluded value, 3. Do you recognize a pattern in this one here? This is the difference of, finish it, this is the difference of two perfect squares. So it gives us what pattern, do you remember?
Sum and difference.
Good, sum and difference pattern. So we end up with x plus or minus what number? What's the square root of 16? 4. Remember when you multiply this back, you end up with the outside inside canceling, right? They're opposites. So what are the two values that would cause the denominator to
Negative 4 and positive 4.
be 0? Good. Plus or minus 4. Either of those would cause that entire denominator to equal 0. Okay, pause the video. Try these. Try to find the excluded values. What would cause the denominators to equal 0? And then come back and check what we found. Okay, so we have found these answers, and we're moving on to number 2 down here. And number 2, again, what might we do? We want to know what would cause that denominator to be 0, right? Is there a y that would make it 0? So could you factor this?
Yes.
What factors? Okay, they're both prime here, right? 5y and 3 are both prime. Is there any arrangement of 3 and 1 that would give us the middle of 2y? No, so this is not easily factorable. So Tara, what else could we do? How else can we solve it? JD? You could complete the square or quadratic formula. Let's use a quadratic formula. Ready? X equals
Negative b plus or minus the square.
b squared minus 4 over 2a. Okay, so when we fill it in, what is negative b in this case?
Negative 2.
Negative 2 plus or minus the square root of 2 squared, which is 4, minus 4 times 5, which is 20 times 3 is 60. Interesting. Over 2 times 5, which is 10. What do you notice about the discriminant, the value that's in the radical? Negative. Do you see this? 4 minus 60? So are there any solutions to this?
No.
Which means there are no zeros. Which means you could put any value for x. There is no excluded value. No excluded value. Because there's no value that would cause that trinomial to equal 0. Isn't that interesting?
So,
Every real number x would cause you to get some real value y that's not 0. It's as though it's opening up above the 0. Right? It's not touching. Okay? And then finally, number 4. Again, we see the same kind of pattern we saw in number, whatever that was there, number 3. We're doing these a little out of order. This is the difference of two perfect squares, which gives you the sum and difference. So let's say the sum and difference together. This gives us m
Plus 2
and minus 2. So the two excluded values that would cause this denominator to be 0 are plus or minus 2. 2 and negative 2. Okay? Good. Kind of hard. Okay. We're going to get into some more sophisticated expressions. What can we do with this expression, AC over BC? You can divide out the C, right? And we could call it A over B. However, because the original expression had AC over BC, what values must be, or what may B never be?
0.
And what may C never be? Even though it doesn't exist in the original expression, neither of them may equal 0. Okay? So, your excluded values here, excluded values are B may not equal 0 and C may not equal 0. Neither one of them may equal 0. Okay?
Is the second one C over C?
Yes. That was just an expanded form. Okay? So here we're going to simplify some polynomials, but we also are asked to state the excluded value, or values. So in A, simplified, Jack, what would that be? 2/3. So we all agree that is simplified form. But what is the excluded value here? What may you not input for x? 0, because it shows up in the denominator of the original expression. Okay? B. B is what looks like a monomial over a 6 times x plus 5. 2 factors, right? But this monomial in the numerator is really 6 times x. This is 6 times x over 6 times x plus 5. So where do you see the multiplicative inverses? Michael?
We're going to do 6x plus 30.
Well, you're distributing in the denominator, I guess. But really, if we're simplifying this, what could we do, Laura? Take out the 6, right? 6 over 6 equals 1. So we could just call this x over x plus 5. Now, can we simplify it further? Really, this is best left just as it is. It's fine. But what is the excluded value? Negative 5. Negative 5 is what is not allowed. There. Dina. Please be sure to check your work with the key and your odd problems and make sure that you're catching these little errors you're making as you go. And then you should be stronger with the even, right? You should be learning along the way. That's why we check the key. So in this one, C, in order to figure out what we can reduce this by, right? What factors are common in both the numerator and denominator, we want to pull out any common factors from the numerator. So what does 8b squared have in common with 16b?
8b.
Good, so we do 8b times what to bring us back to the original?
b plus 2.
b plus 2. So imagine we could multiply by distributing and get right back to where we were. So there we have 8b times b plus 2. 32 is really 8 times what? 8 times 4, and we have b. I'm just factoring this just to show you that you could do this. Often we don't. We just say 4 over, or 8 over 32 we can simplify, right? But it's the same thing, whether we're using numbers or larger factors. The 8 over 8 equals what? 1, right? And the b over b equals 1 as well. So we end up with b plus 2 over 4 as our simplified ratio. That's it. Can we simplify it further? If you did, you would have to say b over 4 plus 2 over 4, which is 1/2. Is that simpler? Not really, no. I mean, I would accept either, I guess, but to me that's not simpler to have two little fractions. So there you go. We have b plus 2 over 4. So what is the excluded value though? Look at the original. What would make that 0? 0. Even though, look at in the simplified expression, I don't see a b in the denominator. However, this expression started here, and so we must include the fact that b cannot equal 0. Okay? Okay, pause the video, come back and see what we got here. So we factored out common factors in the numerator or in the denominator and looked for multiplicative inverses. Notice when everything canceled from the numerator here, we're left with 1 in the numerator, right? Okay, let's try it with dividing out binomials. We just did one where we divided out a binomial. Where was it? Right here, right? We're going to see another one here, but we're starting with trinomials. So factor them and see if there's a common binomial. Okay, so we factored the numerator and denominator and found this multiplicative inverse, right, which equals 1. And we ended up with x plus 4 over x plus 2. And you must stop here. These are not factors. These are addends over an addend or a binomial over binomial, and they're not like binomials, right? The excluded values are based on all the zeros that we saw here. There's one more really complicated thing I'm going to show you right now. Okay, so look here. What is the opposite of a minus b? Good job, b minus a, right? Okay, so there's another way I could write this. If I would like to move the a into the leading term. So what would it be? It would be, say it, JD? Good, so I have it now in the leading term. There's still opposites. Simply moving the term over using your commutative property, that's it. Now I want to factor this negative away from the leading term. Okay, so if I factor out the negative, it would be negative 1 times what? Good, a minus b, right? And a minus b is exactly a minus b. Do you see that? Okay, so let me show you this with this. We'll place a number in for one of these letters here, these variables. 5 minus x, the opposite would be x minus 5. Okay, so if I put these opposites over each other, what happens? We can do the same thing we just did on the left with a and b. I could leave the top alone, but the denominator, I'm going to move the 5 to be in the same location as it's the numerator. When I move it, though, I have to take the sign with it, right? So these are still opposites over each other. Now, if I take the denominator and I factor out the negative 1, right? What's left inside? Negative 1 times 5 minus x. Do you see that? Oh. And so 5 minus x over 5 minus x equals what? It equals 1. But because of that negative in the denominator, we have a value of negative 1. So if I have 5 minus x over x minus 5, what do I have?
Negative 1.
Negative 1, that's right.
Will it always be that?
Always that way. So when you're factoring today, if you come across opposites in the numerator and denominator, they equal negative 1. I mean, really, this is something that you're going to look at and say, wow, that's interesting. I have 5 minus x over x minus 5. It's really interesting. And it comes to you pretty quickly when you see it. So let's try it with this one. If we factor the numerator here, I feel like we've already done this one. But what factors of 10 add up to 7?
5 and 2 and 2.
Good, 5 and 2. Okay, and then in the denominator we have the difference of 2 perfect squares. So we simply have 5 plus x and x plus, that's not right, 5 minus x, right? Now, when you look at the numerator and denominator, do you see the opposites? We have x minus 5 over 5 minus x. So when you do this kind of canceling, you really have to place a negative 1 in the numerator. Okay, so we distributed the negative and we have this expression left. Okay, it's interesting. Okay. And we don't have time for more practice, but you have time for practice.